Good evening. This is my video for the experiment that I'll be conducting for our assignment for the interactive advanced concept presentation for week 1. And specifically, this is going to be a static electricity experiment. So my experiment tonight is going to include a demonstration of electrically charged particles being attracted to a statically charged balloon. But first, I wanted to provide a little background to static electricity for the context of the experiment. According to the Encyclopedia Britannica, static electricity is a familiar electrical phenomenon in which charged particles are transferred from one body to another. For example, if two objects are rubbed together, especially if the two objects are insulators and the surrounding air is dry, the objects acquire equal and opposite charges, and an attractive force develops between them. Here's what else we know. Water vapor works to conduct the charge away from you or an object. Less water vapor means that your body can hold on to that higher charge, and the impact of that characteristic becomes clearer in arid environments. So for the sake of my experiment, my initial observations are this. Static shocks occur more frequently when petting my dog in the winter than the summer. Relative humidity in Anchorage is lower in the winter, as it is in most places, than compared to the summers, and could be the cause of this observation. Currently, the humidity in my house is 22%, and my senses also detect this as being more humid than normal. So we've been having a warm spell of weather lately, and snow is starting to melt, but I still have 4-foot-high snowbanks outside. We refer to this up here as breakup season, as in when the ice is going to break up. But hopefully that also means that spring is on its way. If that's the case, so is dog shedding season, so there'll be some issues there. Okay, so hypothesis is that I believe that placing a balloon with significant static electrical charge near a mixture of salt and pepper will result in particles of the salt and pepper being attracted to the balloon due to the overall negative static charge of the balloon. My process for the experiment will be to rub my balloon against my hair, but first I want to measure out my salt and pepper. I have a plate here, and in each of these brown cups I have a sum, not measured, of pepper and salt. This is 1/8 of a tablespoon, approximately 0.63 mLs, and that will be my deposit of pepper. My deposit of salt is a pink Himalayan sea salt, a very fine grain, and that will be mixed in. This mixture is not homogeneous. It is a mixture that it does not have consistent diversity of particles, but I also attempted to counter that with the fact that I'm using the same proportion. So I now have a mixture of Himalayan sea salt and black ground pepper on my plate. I need to set that aside for a second, and now I'm going to statically charge my balloon. I thought about doing this with my dog, but he would hate me, so I've got the hair for it. Vigorously rub, vigorously rub. I'm attempting to transfer the electrons that are in my hair to my balloon. And I can tell that I've done that because of how much the balloon and hair are attracted to each other. So, taking the same surface of the balloon, that is towards the camera, I'm going to bring my plate close and I will hold it over and see what my particles do. I see a very significant attraction of pepper, some salt, involved, but there's a significant amount of salt remaining on the plate. So, why do we think this is? My poor dog thinks the world is exploding right now. Okay, I've observed my attraction, the attraction of the particles. First off, rubbing the balloon against my hair causes electrons to move from my hair to the balloon. Because electrons are negatively charged, balloon acquires the net negative charge. Particles of both salt and pepper were attracted to the balloon, but predominantly more pepper than salt. And I have two reasons to speculate why this is. I believe that, one, the particles may differ in their net positive charge. So therefore, their attraction to the negative charge of the balloon would vary. Also, I believe that particle size could be a factor. In this experiment, I was using a fine-grained Himalayan sea salt. However, that may still vary in terms of mass as compared to the grains of pepper. In terms of trying to establish a clear relationship, further experimentation would be required to get a more precise understanding of the mass of each of those particle sizes. And I also believe that further experimentation would be needed to establish the individual charges of the pepper versus the salt charge. That might help us understand why one particle of pepper was more attracted to the balloon over salt. Okay, that's my static electricity charge. I hope you guys have a great night.